Throughout this PowerPoint, I'm going to talk about the method of collecting data for the numerical model. This will include the method of the jump and how each person will perform the jump, and how the camera will be set up to achieve the correct positioning and the correct angles. Throughout this, I will be analysing the method in recording the individual's jump, and how the camera position will affect the different angles of an individual, and what plane of motion an individual is in. To prepare the participants for the test, they must fill in a PAR-Q. This is a physical activity readiness questionnaire. This is so the individual is able to use the force plates, or if the individual had any injuries, the researcher will then check through PAR-Q and make sure that the individual is able to do it. The participant must also do a warm-up and stretching so that it reduces the chance of pulling any muscles. This had to be done, otherwise injuries may occur. Also, they should do a practice jump so it's a fair test. Within this test, there are going to be 3 protocols. The protocols were explained to the participant before doing the jump so they knew what they had to do. The protocols given to the individuals must be the same so that it's a fair test and they both know exactly what they need to do. The 3 protocols were CMJ, which is a countermeasure jump. This is when they're able to jump however they want, with their legs being whatever angle they want before they jump. So if you go down more, you'll get more of a leverage to push back up and hopefully more force, so therefore you'll go higher. Whereas if you started with straight legs, then it's more likely that you won't go as high. The other protocol was a 45-degree angle jump. This is measured by a goniometer, which is an angle measure. It's put on the knee and it will measure what angle the legs are at. The last one is a 90-degree angle. Once again, it will be measured by a goniometer. With these 2 angle jumps, the individual must try and stay that degree before they jump. If the individual goes down before, they'll get more force to push back up. If the individual holds themselves in the 45-degree or the 90-degree angle for too long, they may get muscle fatigue because they're holding the isometric traction for so long. The force will be measured by the force plates, and the movement will be measured by the cameras. And the cameras will measure the stickers that are put on the participant's knee, hip, ankle. All the equipment should be calibrated before use to make sure it's a fair test. By calibrating all the equipment, it will make sure it's back to 0. So the participant before may have had a different score and it may have stayed on that, but then the force to be applied again, and it could be double the score, therefore it would not be a fair test and the readings would be wrong. To get the best out of all the readings, you should do 3 of the same, so 3 of the 45-degree angle and the 90-degree angle and the CMJ jump. So by doing this, you can add them all up and divide them so you'll get a mean total. Filming can be done in 2D or 3D. The filming will be affected by the type of clothing people are wearing, because if they're wearing trackies may cover the markers on the participant's legs, and therefore the filming won't work as you won't be able to see the markers. Also, the camera needs to be a high-speed camera, so to be able to take lots of shots per second. Also, it must have a high shutter speed. However, by doing this, less light will be able to enter, which means that the outcome may be a very dark photo. Also, the camera must be exactly side-on to the participant. This is so that the angles are measured correctly. This is done by triangulation. So you must measure out exactly where the individual is going to be and to where the camera is going to be, so it's side-on. Otherwise, the angle of its side-on may be different to how it was if you were standing a meter on right or left. Also, you must keep their whole body in film while filming, because if they jump, you need to account for enough room upwards, otherwise you may chop off their head in film. There are different types of planes of motion of an individual. There is sagittal plane, which is side-on, which you can see here. There's frontal, which is obviously front-on, and transverse, which is the upper half or the lower half. The frontal plane is adduction and abduction, and the transverse plane is mostly for rotation, whereas the sagittal plane is for flexion and extension. This is my data collection for what I've done, and I will analyse and compare them in 6.4.